There are three forms of OCI persistent storage that all OCI users need to know about. We have the object store, block storage, and file storage. For people familiar with Amazon Web Services, there are very close analogies between the object store and S3, block storage and EBS, file storage, and the EFS, Elastic File System. Today, I want to talk about the storage devices that can be attached to compute instances. These are block storage devices and file storage. We'll leave the object store for another day. So first, block storage. When you first create an OCI Compute instance, it will have a boot volume, minimum size 50 gigabytes. This machine, called Web1, is a little one I created using the Oracle 8 image on an E4 Flex shape. And here's the one disk. So one disk, SDA, and you see the boot partitions, and then there's a 35 gigabyte partition mounted as the root file system. And this device, SDA, is what they call a block volume. It's a virtual disk presented to Unix as a block device. And block volumes have all the characteristics you'd usually want in terms of fault tolerance, encryption, performance. Usually, you'll want to add at least one more. So let's create one. I'll do it using the OCI console because that will be the easiest way to do it. So create block volume. I shall give it a name. I shall just call it my volume. I'll create it in this compartment, JW compartment. And note the availability domain. I'm going to put this one in availability domain AD2. And the reason for this is that volumes are AD specific. They're availability domain specific, and they must exist in the same availability domain as the instance that is going to use them. I'll specify the size as 50 gigabytes, which is the minimum we can have. Performance, maybe I can save a bit of money by bringing it down to the lower cost level, and then create the block volume. That will just take a couple of seconds. And when it is created, I'll attach it to the instance. So, navigate to my compute instance. I've got two compute instances that I can use here, Web 1 and Web 2. Web 1 is in availability zone domain 2, and my Web 2 instance is in availability domain 3. So if I choose that one, attach block volumes, and attach the block volume, and this will show me the volumes that I have access to, which will be that one that I just created. For the attachment type, I'm going to take paravirtualized. iSCSI may be a bit faster, but it's a bit more complex to work out to configure, whereas paravirtualized, there's no configuration needed at all. I'm going to make it a read-write attachment. Shareable is what you would use if you were creating block volumes to use as ASM disk devices. But I'm going to put a file system on this, so I'll have it read-write and attach. It's attaching now, and within a very few seconds, I should see it. And I see it already here. Device SDB is a 50 gigabyte device, and as yet, not partitioned. To bring it into use, I need to do a bit of work at the Unix level. First off, I'll give it a label and a partition table. And that's just with part-ed, label it with GPT. Then I need to create a partition. And I've covered the entire disk with one primary partition. Create a file system on it. And I'm going to use mkfs-t ext4, so format it with ext4, which will take a few seconds. That's done. Create a mount point, mnt myvol, and mount it with mount-type ext4, first partition sdb on mnt myvol, and here it is. So that's block storage. Very, very straightforward. However, it has two possible problems. First, the device has to be in the same availability domain as the instance on which you intend to mount it. Second, you can't mount a device formatted with an ordinary file system, such as ext4, on several instances at once. And that's where the file storage mechanism comes in. File storage leverages NFS to make a file system that is shareable across all the instances in your virtual cloud network. So to summarize, block volume storage, everything you would want in a disk, but it does have a couple of issues. Those we'll fix by going to the alternative, which is file system storage. File system storage is a regional service. You create the virtual device, it is exposed as an NFS export, and all instances in all availability domains can see it. They mount it using a standard NFS client. The first step to enabling file storage is to adjust the security list of the subnet on which the file system will reside in order to permit NFS. So we go to networking, virtual cloud networks. The subnet I'll be working on is in the workshop VCN, and I'll put it on the private subnet and check out its security list. I've already configured this, and the critical point is we need to add ingress rules to permit the NFS protocols. And I've done them down here. So we are accepting ports 2048 to 2050 and also 111 for the port mapper for both UDP and TCP. And I'm permitting that access from anywhere on my VCN. Having done that, the next step is to create the file system. File storage there, and create a file system. Give it a name. I shall call it MyFS. Choose an availability domain. It doesn't matter which at this point, because all instances in all availability domains will be able to use it. My compartment. Defaults will do for everything else. The export path, the mount target information are basically the same as the name I chose above, and create. It will take a few seconds. And now it's done. To mount the file system, OCI will have generated the necessary commands. And if we look at the menu here, we can see the mount commands. Note it does give you a bit of advice about configuring your security rules. I did it in a security list. Network security group would be an alternative. It's telling you here what ports need to be opened for ingress and for egress. And these are commands suitable for mounting it depending on your operating system. I'm using Oracle Linux. So, pull up my instance, and first off, I've already got the NFS utilities installed, but I'll create the mount point and then run the mount command. df-h, and there it is. All of a sudden I have access to an potentially 8 exabyte NFS file system there. And what I want to do next is mount it on my other instance. So this is my Web 2 instance, but Web 2 is actually a different availability domain. That isn't a problem at all. I can create a mount point on this machine and mount the device with the same command on this one as well. And just to complete the demonstration, I'll create a file. That should just touch, oops, touch a file called Made on Web 2, go to the other machine, and there it is. And it is, of course, read-write. So if I wish to, I can create a null node and do any sort of updates on another. And that really is it to configure persistent storage for compute instances. You have block volumes up to 32 terabytes, and they are, in effect, fast local devices. The alternative, file system devices. These are shareable, region-wide NFS exports that can go to 8 exabytes. The third form of storage that OCI practitioners will usually be using is the object store. And that's globally accessible, accessed over the web, typically through RESTful services, and that we'll talk about next time.
If you liked this video, please like it and subscribe to our channel.